We're off to a new lecture module, and this module is called Recognizing Laboratory Hazards. So you're probably scratching your head thinking, well, haven't we done this already? And the answer is, yeah, we have, somewhat at least, but we need to talk more details, right? The devil's in the details, and we need to get to those details. Because if I'm working in a laboratory, I want to know what's around me. I want to know what I'm exposed to. I want to know the types of chemicals that I'm going to have to work with. And I want to know what hazards are associated with those. Now, not just chemicals, but I also want to take a look at the way the laboratory is made. So, safety showers and fire extinguishers, yes, that's part of the picture. But there's other components of a laboratory that we're going to have to maybe take a closer look at. Maybe we had no clue that those types of things were going on in a lab. But hopefully after this module, we'll start to recognize all of those things that you have taken for granted up to this point. So the key here is this word called hazards, right? And there's going to be a big question mark beside of that because we want to know, what does that actually mean? And we're going to start off talking with chemicals again, because we're going to go into more details of things that we've mentioned in previous modules. So some of this is going to be a review, but at the same time, some of it is also going to be new information that we're going to learn about as we go through this module. All right, so like I've done always before, we're going to start off with an incident. And this incident says, a high school staff member. All right, so first off, this is an employee of an educational institution that is working in a science laboratory. Keep that in mind. A high school staff member was preparing the lab for an upcoming science class when she dropped a bottle of bromine and it broke. So a lot of you would say, well, this is kind of an accident, right? And we said, well, there's no really things as accidents. There are things that we call incidents in a laboratory. This is an incident that happened. So let's see how she took care of it. She dropped a bottle of bromine and it broke. She was surprised. And before she could do anything, she inhaled some of the bromine. She was taken to the hospital in moderate condition. And bromine is a highly corrosive, moderately toxic by inhalation, and exposure can cause coughing, tightness of the chest, headache, nosebleed, and dizziness. So, we're going to give credit where credit's due. Number one, this is an incident that does not happen very often. If you wanted to call it an accident, you probably could, because I don't think this high school staff member would be dropping bottles of bromine every day. This was just something random that happened on this particular day. Bromine is a liquid, but bromine goes into a gas basically at room temperature. So in the bottle, we get a liquid solution, and then as soon as you pour it into a beaker, this thing starts to turn into a gas, and it will fume, and it stinks. It almost has a very similar smell as a swimming pool in the middle of the summer. It's that disinfection kind of chlorine smell that people associate with liquid bromine. The problem here, though, is that the directions, or maybe the SDS on the bromine, says that it's very toxic. And this word we're going to have to get to. We're going to have to kind of understand what this term toxic means, and what is toxic and what is not toxic. And then maybe we'll have a better understanding of the precautions that we need to take when we're working with chemicals like liquid bromine here. Good thing, though, she went to the hospital. She was monitored. Everything was okay. But if that step was not taken, this could have led into chemical pneumonia, and it could have led into death. So these are the things that we're going to have to keep in mind when we're working in a laboratory, right? It might not be your fault. It might just be a, quote, accident that could happen, And we have to be okay with that. But at the same time, we cannot have any hesitation. If you're working with liquid bromine, you should know the hazards associated with that bromine. And if this word says toxic, then we're going to have to figure out what that term actually means and what does it apply to. So that's where this lecture is going to start off. All right, we're going to kind of go over some new definitions that maybe you have no clue, or maybe you think that you have an idea, but you're not really sure if you're correct or not. And the very first one that we're going to talk about is this word called toxicology. All right, so if you had to define toxicology, hopefully what you would say is that this is the study of adverse effects. Adverse is typically applied to not so good, all right? These are side effects that are detrimental to you, but study of adverse side effects from chemicals. And I said side effects, but notice I didn't write that down, and that's because people think that, well, they're side effects, so you shouldn't really pay attention to them. No, it's adverse effects. All right, we would associate these with side effects if it was a prescription, but it's an effect. And it could be a good one or it could be a bad one in terms of the prescription drug that you're getting from your pharmacist. But some of the chemicals, there are no good ones. So adverse effects from chemicals. Okay, AKA, it's the study of poisoning. It's really what it is, folks. And that's what this lecture is all about and this module is all about. It's about poisoning. What is that term? What does it mean? What chemicals are poisonous? And how can I prevent poison from happening to me? All right. Another term that we can define maybe is toxicity. Very similar to toxicology. I know it probably has something to do with toxic chemicals, right? Well, the definition of this is it's the ability of a chemical to damage an organ or biochemical process. So here's the jagged little pill to swallow. And you Alanis Morissette fans back in the 90s would appreciate that. What you have to understand, and I'm going to change the color here to write this statement because it's pretty important. All chemicals, every single one of them, have the possibility of being toxic. That's right, folks. Everything you work with. Can you imagine going into a lab with the knowledge that you have now that everything around you could actually be toxic? And if it's toxic, then that means maybe poisoning, or at least you would associate that with poisoning. And then you would think, everything around me is poisonous. I'm going to die. Well, no, it doesn't quite go that far. So we're going to kind of clear up this definition a little bit, but you do need to understand that all chemicals have the possibility of being toxic. And I'm going to put in parentheses here, yes, even water. Water could be toxic. Now I see where he's going with this. Everything that you expose yourself to could be a toxic compound. Even water. So that means there's got to be something else to this definition or to this field of toxicology that we haven't made it to yet. And the answer is yeah, we'll eventually get there. However, first I want to go back to this previous statement. Toxicity is the ability of a chemical to damage an organ or a biochemical process. So that means, yes, water can be toxic. So therefore, water has the ability to damage an organ or a biochemical process. All right, well, if we're talking about organs, what typically are we really focused on? Well, it seems like everything that our body absorbs, whether we inhale it or whether it absorbs through our skin or whether we drink it or eat it, it has a tendency to either go through the kidneys or through the liver. So those are the two organs that are always focused on. And we'll talk more about why a little bit later on in the lecture module. But kidneys and liver are always the main organs of focus. Now, that doesn't mean that things like your heart and your brain are not important. That just means that these two are the typical ones that get affected first. And we'll see why a little bit later on. What's a biochemical process? Well, a biochemical process would be processes that your body is doing. And these chemicals will interrupt that process. So, for instance, hemoglobin. Hemoglobin is what carries your oxygen to your extremities. How does the oxygen get to the tips of your fingers and the tips of your toes? Right? That's all the deal with hemoglobin. If something interferes with the hemoglobin, bad things will happen and you can die. So this is the biochemical process that is getting interrupted. So these toxic compounds will do one or the other. They'll either target the organs, shut them down, or destroy them. Or the toxic compounds will target not an organ, but a process that your body goes through in order to do a specific job. All right, another definition that we can bring into the picture is something called a toxicant. A toxicant is a chemical producing toxic effects. So, for instance, water can be a toxicant because water, under the right circumstances, could target an organ or a biochemical process and shut it down. Because of that, water has toxicity associated with it. And toxicology is the field of science that studies all of that. Toxicants can be natural occurring. Mother Nature is a mean one. She makes all kinds of toxins. So, for instance, a toxicant that would be natural would be something like nicotine. Yeah, we'll get to that a little bit later. Or a toxicant can be man-made. If it's man-made, this would be something like a dioxin. Typically, we've done it in a lab for some type of purpose. It seems like pesticides and herbicides are always the ones that we're focused on because we spray those chemicals all over our plants, all over our herbs. We spray them all in our fields to let those tomatoes and the corn grow. And as they grow, they are exposed to these pesticides and herbicides that are laboratory made. Well, what happens if we eat that? That's a compound that we are ingesting. So what would go on, right? We need to talk about those types of things. And finally, the last definition is a toxin, Toxin. And this is a chemical that's a toxic chemical made by a plant, an animal, fungi, or bacterium. This would be something like snake venom. So these are the things that we're going to be talking about in this lecture module. And in the next video, we'll pick up with these topics, with these definitions, and we'll go forward.